guys, welcome to lesson 8.2. We're going to work on solving equations when you have variables on both sides. We worked previously on solving equations where you had to combine like terms. This may happen some in these equations also, but what's different is the fact that now I have like terms, but they're on different sides of the equal sign, which means I can't treat them the same. I have to do something different for a problem like this. If I want something to go from one side of the equal sign to the other, the whole term, if it's a variable, I'm going to add or subtract it. So if I want to take this 3a and move it to the other side with the 5a, I can't just put them together. I need to subtract 3a from both sides. Think about moving it over this big retaining wall here. I've got to do something different, so I'm going to have to subtract 3a from both sides in order to move it to the other side of the equal sign. So when I do that, 5a minus 3a is going to give me 2a is equal to the 3a minus 3a canceled out. So I'm just going to have a negative 8. That allowed me to move that 3a over there to the same side with the 5a so that I could combine those terms. But I can't just put it together. That's why I had to subtract it. Okay. Then to solve, I have to get rid of what's in front of the a. That's the 2. It's being multiplied, so I want to do the opposite, and I want to divide. So I'm going to end up with a is equal to negative 8 divided by 2 would give me negative 4. Okay, let's look at another one here. This time I have two different things I want to move. I want my b's to be on the same side together, and I want my numbers to be on the same side together. So it's like I want to take my 3b and move it over here, and I want to take my 12 and move it over here. So to take my 3b and move it to the left, I'm going to subtract it. So 2b minus 3b, it's going to give me negative 1b plus 12 would equal 8. And then to take my 12 and move it to the other side, I'm going to subtract it. That's going to give me negative 1b. It's going to be equal to 8 minus 12 would give me negative 4. Then to get the b by itself, I have to get rid of that negative 1. So I'm going to divide both sides by a negative 1. And I end up with b is equal to 4. Okay, for the next problem, I need to simplify over here on the right side before I start moving things back and forth. So I'm going to simplify by distributing just like we've done in the previous lesson. So I have 6n. It's going to be equal to 3 times n, which would give me 3n. 3 times 7 would give me plus 21. Now this problem is very much like the first one. I'm trying to take the 3n and move it over here to the other side. I'm going to do that by subtracting 3n from each side. 6n minus 3n would give me 3n equals 21. Then to solve it, I need to get rid of what's in front of the n by dividing by 3 on each side. And I end up with n is equal to 21 divided by 3, which would give me 7. For the last one here, I have a couple of different things that I need to simplify. So on this side, I need to distribute the 3. On this side, I need to distribute the -2. So when I do that, I'm going to have 3r plus 6 is going to equal -6r plus 6. Oops, that's not a 6. Try again. There we go. So when I go and get started here, so I need to move my r's to the same side, and I need to move my numbers to the same side. So let's start by taking this 6r and moving it over here. This time, the 6r is negative. So if I want to move it to the other side, I'm going to need to add 6r to both sides. So it would give me 9r plus 6 is going to be equal to 6. Then the 6 is positive, so I'm going to subtract 6 from both sides, which should give me 9r is equal to 0, because 6 minus 6 is 0. But that's okay. I'm going to divide by 9 on each side. 0 divided by 9 would give me r is equal to 0. And that's my final answer for this problem. Let's go through some book examples here as well. Same idea. We haven't changed our strategy for these. Put all of these kind of I think having this line here helps you visually see a boundary that reminds you I can't just put together the 7x and the 5x. I'm moving the 5x to the other side, for example, in the first one. So I'm going to need to subtract it. That would give me 2x is equal to 16. And to solve it, I need to then divide both sides by 2. I end up with x is equal to 8. On the second one, I'm going to use that one to kind of show you the second and the third to kind of show you some of the weird things that you can do that look a little different, but it's the same process. So for this second one, if I move the x over here on the same side with this 8x, then I'm going to leave nothing over here, which would just leave that equal to 0. So when I subtract x from each side, I have 7x plus 5 equals 0. And a lot of us begin to panic right here and do some weird things, but just keep following through your steps. I now want to move the 5 over here. I'm going to do that by subtracting. So I end up with 7x is equal to -5. Divide both sides by 7. Just leave it in fraction form. X is equal to -5/7. Okay. However, I could also do it this way. If you notice on the left side here, I have a 2x, and on the right side here, I have a 5x. Some people always move whatever's on the right over to the left. But you could have done the previous problem this way. I can move what's on the left over to the right side. It doesn't matter which side I put my x's on. So this one I'm going to do it the other way. Because 5x is the bigger number, I'm going to move 2x over there. So I'm going to subtract 2x from each side here. So I end up with 9 is going to be equal to 3x minus 3. Okay. Then I need to move my 3 over to the other side by adding. Which will give me 12 is equal to 3x. To get the x by itself, I need to get rid of that 3. I'm going to do that by dividing each side by 3. 12 divided by 3 is going to give me 4. So you can see it doesn't matter. Either way, it could go and still end up getting the same answer. Okay, final one here. Subtract 3x from each side. I end up with 4x minus 5. It's going to equal 10. Move my 5 to the other side by adding. So I have 4x is going to be equal to 15. So to solve it, I divide each side by 4. I end up with x is equal to, leave it as a fraction, that's absolutely fine, as 15 over 4. Okay. So let's clear what's there. We'll get a couple more examples from your book, just 2 more here. These involve simplifying first before we move things back and forth across our equal sign. So on the one on the left, I'm going to distribute the 4. On the side on the right, I'm going to distribute a negative 2. So it would say 4x minus 12 equals, then distribute my negative 2, negative 6x minus 22. Okay, I'm going to move the 6x by adding it because it was minus. So I would have 10x minus 12. It's going to be equal to negative 22. Move the 12 over. So I would have 10x is equal to negative 10. Divide by 10 on each side. So I end up with x is going to be equal to negative 1. And that's your answer for this one. Okay, for the last one over here, I'm going to distribute first. But then you noticed I have this little negative 8 there. So this time I'm going to have to distribute and combine like terms before I start moving things back and forth. You want to simplify everything on the left and everything on the right before you start moving things back and forth across the equal sign. So negative 3 times x is going to give you negative 3x. Negative 3 minus 4 is going to give you negative 12. And then minus 8 is going to equal 3x plus 4. Then I want to combine my like terms here. So I have negative 3x. Negative 12 minus 8 is going to give me negative 20. It's going to equal 3x plus 4. Now I can move stuff back and forth. So I'm going to subtract 3x from each side. Be careful, I have a lot of you who will tell me negative 3x minus 3x is 0. But negative 3x minus 3x is really negative 6x minus 20 is going to equal 4. add 20 to both sides. So I end up with negative 6x is equal to 24. And to solve it, I'm going to divide both sides by negative 6, which gives me x is equal to negative 4. Remember that when you're working these, you first want to make sure that everything is simplified on each side of the equation. Then you can start moving things back and forth across the equal sign.